Hi everybody. In this problem, they're telling us about two cities, City A and City B. So City A is home to 16,000 people, and the population has been growing at a continuous rate of 4% per year. Well, City B is got right now has 9,000 people, and the population has been growing at a little bit higher rate of 5% per year, right? They want to know in how many years will the populations be equal? Will A and B have the same population? So we're going to have to use our, our exponential growth function. So this is the population function equals PO, which is the starting population, times e to the kt. T is time. In this case, it'll be in years. And K is the exponential growth rate, which guess what? That's what the 4% and the 5% are. Okay, so we just have to figure out what they are for each city. So let's see, for City A, the population function is going to be its original population, starting population of 16,000 times e to the, okay, what's K? K is the growth rate, which is 4%, which written as a decimal is 0.04. T is T. So you got to do the same thing for City B. They started off with 9,000 and 0.05 growth rate, right? So what do we have to do? We want to find out when will they be equal. So we want to set these two functions equal to each other and solve for T. So the first thing I would do is probably divide both sides by 9,000. So when you do that, what do you get? Divide both sides by 9,000 and then both. I'm going to try to get all numbers on one side, e's on the other side. So I'm going to get 16 over 9 when I divide both sides by 9,000. Then I'm going to divide both sides by e to the 0.04. So it would be e to the 0.05t over e to the 0.04t. Okay, so who remembers the trick now that you learned probably a long time ago? If you take the natural log of both sides, right? Oh, but first, I'm going to simplify this. Let's simplify that. So that's just simplifies, you subtract, right? So that's e to the 0.01t. You subtract the powers to get that e written as a single instead of a fraction, right? So, okay, now, so that's is equal to 16 over 9, right? So now I'm going to take the natural log of both sides. So when you take the natural log of an e to the something, do you remember what you get? You just get an e to the something. So let's see. So if we take, I'm going to take the natural log of ln of 16 over 9 equals the natural log of e to the 0.01t. So let's see. I'm going to solve for t. Oh, what can we do here? What can we do here? We have an e to the 0.01t. We can, because that's an e there, remember the rule, you can move that in front. So that's equal to 0.01t ln of e. Okay, so you have to go back to your log rules that you learned probably a long time ago. So now I'm going to just get t all by itself on one side. T equals ln of 16 over 9 divided by 0.01. Because the ln of e is just 1, if you remember that too. Okay, so then you got to whip your old calculator out, and I got 57.5364. So there's a lot going on in this problem. You have to remember all your rules about your e's in your natural logs and being able to move stuff in front. When you have ln of e, you can move that to the front. Okay, I hope that helps, and it shouldn't be too bad. See ya.